Welcome to the fuel lesson. In this lesson, you will learn how fuel is stored and how the system operates. The fuel system supplies fuel to the engines and the APU. Fuel is stored in a center tank, a left main tank, and a right main tank. There are also two surge tanks located outboard of the main tanks. Controls for the fuel system are located on the overhead panel. Review the fuel system controls before pressing the Continue button to resume the lesson. Fuel indications are displayed on the primary ICAS. Additional fuel system indications are displayed on the fuel synoptic. Review the fuel system indications before pressing the Continue button to resume the lesson. The left and right main fuel tanks each hold 16,776 kilograms of usable fuel. The center fuel tank holds 67,899 kilograms of usable fuel. The total fuel capacity is 101,451 kilograms of usable fuel. Fuel quantity is measured by sensors in each tank. Total fuel quantity is displayed on the primary ICAS display. Tank quantities and total fuel quantity are displayed on the fuel synoptic display. Expanded fuel indications are displayed on the primary ICAS when any of the following non-normal conditions occur. Fuel temperature is displayed in white on the primary ICAS display. The temperature will display in amber when the fuel temperature approaches maximum or the fuel temperature approaches the fuel freeze temperature entered in the Flight Management System CDU. Fuel temperature and minimum fuel temperature are also displayed on the fuel synoptic display. The Nitrogen Generation System, or NGS, provides automatic full-time flammability protection for the fuel system. The NGS generates nitrogen-enriched air to displace oxygen in all fuel tanks. The nitrogen-enriched air minimizes fuel flammability during normal flight and ground operations. The two surge tanks, located outboard of the main tanks, are used for fuel expansion and venting. The vent system connects the center and main tanks to the surge tanks. Each fuel tank contains two AC-powered fuel pumps. A single pump can supply sufficient fuel to operate one engine under all conditions. The two center tank fuel pumps are override jettison pumps. These pumps have a higher output pressure than the left and right main tank fuel pumps. When operating, the center tank pumps will override the main tank pumps so that center tank fuel is used before wing tank fuel. When the main tank fuel pump switches are off, the switch pressure lights illuminate, and the ICAS advisory messages fuel pump left, right, forward, or aft display. When the center fuel pump switches are off, the switch pressure lights and pump pressure ICAS messages are inhibited. Before start, the main tank pump switches should all be pushed on. If the fuel in center message is displayed on the primary ICAS, the center tank pump switches should also be pushed on. During flight, when the fuel low center message displays, the center tank pump switches should be pushed off. With the main tank pumps on, a scavenge system operates automatically to transfer any remaining center tank fuel to the main tanks. Fuel transfer begins when either main tank quantity is less than approximately 16,000 kilograms and the center tank pumps are off. The scavenge system is inhibited if the engine is on suction feed. When main tank fuel pump pressure is low, each engine can draw fuel from its corresponding main tank through a suction feed line that bypasses the pumps. Be aware when operating on suction feed at high altitude, thrust deterioration or engine flameout may occur. This is the result of dissolved air being released from fuel in the tank as the airplane climbs and air pressure decreases. The dissolved air may collect in the suction feed line and restrict fuel flow. In this condition, fuel pressure can be provided from a main tank with operating fuel pumps to both engines by opening the fuel crossfeed valve. However, continued crossfeed use results in a progressive fuel imbalance. After reaching cruise altitude, the dissolved air in the fuel tank will eventually deplete. The depletion time is dependent on airplane altitude, fuel temperature, and type of fuel. Once the dissolved air is depleted, the engine should effectively operate on suction feed. If an engine or generator is not operating, there may not be sufficient electrical power to operate all fuel pumps. In such cases, the fuel system automatically determines the best pumps to operate depending on how much electrical power is available. The system will then load shed certain fuel pumps until enough electrical power is available. If a fuel pump has load shed, the corresponding pump switch pressure light is illuminated, and the corresponding pump is labeled load shed on the fuel synoptic. When the fuel quantity in the left and right main tanks differ by a predetermined quantity, the ICAS alert message fuel imbalance is displayed, expanded fuel indications are displayed on the primary ICAS, and a solid amber fuel imbalance pointer appears on the expanded fuel indication next to the low tank quantity. The difference in fuel quantity which causes the fuel imbalance message to be displayed varies with total main tank fuel quantity. If the fuel imbalance message is not displayed and main tank fuel differs by more than 100 kilograms, the fuel imbalance pointer is displayed in solid white instead of amber. The fuel imbalance pointer will also display in solid white when the crossfeed valve is open or the balance system is on. Fuel balancing can be accomplished using the fuel balance system or the manual crossfeed. The fuel manifolds are arranged so that a fuel tank pump can supply either engine. Normally, the crossfeed valve is closed to isolate the left and right systems. However, crossfeeding may be accomplished in any phase of flight. Manual crossfeed is initiated by opening the crossfeed valve and turning off the fuel pump switches for the fuel tank that has the lower quantity. If the valve position does not agree with the switch position, the crossfeed switch valve light illuminates, and the ICAS advisory message Fuel Crossfeed is displayed. Fuel can be transferred from main tank to main tank using the fuel balance system. The fuel balance system may be used in any phase of flight. The fuel balancing system can also be used on the ground if the engines are shut down but the APU is running. Fuel transfer is initiated by pushing the fuel balance switch on. Fuel from the higher quantity main tank is transferred through its defuel jettison valve to the lower quantity main tank through its inboard refuel valve. Transfer stops automatically when fuel is balanced. Anytime the fuel balance system is selected on and balance is not achieved, the balance system shuts down, the balance switch fault light illuminates, and the ICAS advisory message Fuel Balance System is displayed. This will occur if there is a system failure or if the system is functional but inhibited. Fuel balance operation is inhibited for any of the following reasons: refueling, defueling, and ground transfer of fuel, prior to engine start and the APU is off, the fuel balance system is failed, a center tank pump is on the ground and one or both engines are running, or in flight and the fuel jettison system is active, or the fuel disagree or fuel quantity low message shows. APU fuel is supplied from the left fuel manifold. APU fuel can be provided by any AC fuel pump supplying fuel to the left fuel manifold, or the left main tank DC fuel pump. APU fuel pump operation is completely automatic. Both AC and DC fuel pump indications are displayed on the fuel synoptic. On the ground, with the APU switch on and no AC power available, the DC fuel pump runs automatically. Once AC power becomes available, the left-aft AC fuel pump operates automatically regardless of fuel pump switch position, and the DC fuel pump turns off. The fuel jettison system allows jettison from all fuel tanks. Fuel jettison is accomplished by opening the center tank jettison isolation valves and the main tank defuel isolation valves. Fuel flows into the jettison refuel manifold and is then jettisoned overboard through jettison nozzle valves inboard of each aileron. The fuel jettison process is initiated by pushing the fuel jettison arm switch to armed. When the jettison system is armed, the to remain quantity indication replaces the fuel temperature indication on the ICAS display, and the to remain quantity and jettison time are displayed on the fuel synoptic. Arming the jettison system will also automatically set the fuel to remain to the maximum landing weight fuel quantity. Pulling the fuel to remain selector to on will change the mode from maximum landing weight to manual, allowing manual selection of the fuel to remain quantity. While in the manual mode, rotating the fuel to remain selector clockwise increases the fuel to remain quantity, and rotating the fuel to remain selector counterclockwise decreases the fuel to remain quantity. Pushing the fuel to remain selector returns the mode to maximum landing weight fuel to remain quantity. Pushing a fuel jettison nozzle switch to on while the fuel jettison arm switch is armed opens the defuel isolation valves and the jettison isolation valves, and opens the corresponding jettison nozzle valve. The fuel jettison nozzles cannot open on the ground, regardless of switch positions. The fuel system automatically positions the valves as required to jettison fuel based on the selected to remain quantity. When a value just above the fuel to remain quantity is reached, jettison automatically stops, and the defuel isolation valves and the jettison isolation valves close. The fuel jettison nozzle valves must be closed manually by selecting the fuel jettison nozzle switches to off. After jettison is complete, at least 3,900 kilograms of fuel will remain in each main tank.